than slab and glide avalanches and some of the more complicated things that I'll gladly leave to other people who have more experience. So I'd like to acknowledge Simon Troutman just for some good quality time on the phone and in person. He's been spending too much time in Colorado over the last couple of years. I have been having knee surgery, just hanging out in Vail, and he let me use a bunch of his work in his graduate work here at MSU. So the objectives of this talk, kind of wet snow and avalanche 101, review some basic things, and then move into characterizing wet-loose slides, contributing factors with that, and a little bit about wet-loose forecasting. So avalanche classification 101, slab avalanche on the left. Doesn't matter if it's wet or dry. What do we need? What do you have going on with slab avalanche? Alan McClain.
Slope, slab, trigger.
Weak layer.
Weak layer, yeah. That's it. That's it in a nutshell. So you need to have slab. What is a slab? It's just a cohesive snow that's stronger than what's below it. The weak layer is just weaker snow, something that you're going to be able to propagate a fracture. Do you need to have a trigger for a slab avalanche? Not necessarily. You can have naturals. You don't need some skier popping on it or a big slide hitting it from above, whether it's wet or dry. That happens to be a wet slab up in the bowl at Big Sky after the place closed some years back. Then loose avalanches, loose snow. What's going on there?
Loss of cohesion.
Loss of cohesion. So there is no slab. You're just losing cohesion. You get up to that point where there's not enough cohesion. You're past the angle of repose where it just fails. It just starts flowing downhill. Do you need a trigger? Actually, you do. You need some sort of physical disturbance on the surface to really get that thing going. You typically don't see just a loose slide like this just happen. You see, and it's hard, but there's a little roller ball that comes down and then starts entraining snow and entrains more snow and then kind of flares out, which is kind of a typical setup for the deeper loose snow, wet loose avalanches. So wet versus dry comparison. Dry avalanches caused by putting too much additional stress on the snowpack, so it's a loading issue with dry avalanches. Wet avalanches, decreasing the strength. Fundamental difference there. Hit on that a little more in a minute. How do they involve people? The victims or someone in that party triggers it 90% of the cases with dry avalanches. Wet avalanches. Most accidents are from naturals. As far as difficult for people to trigger, wet loose avalanches aren't really. When the conditions are right, it's pretty easy to trigger wet loose avalanches, right? And all the people here have played it, you don't have trouble getting things rolling. It's fun when you're out there destroying stuff when the conditions are right. I think a better term might be with wet slabs, same thing. If the timing's right, it's not difficult. It's rare for people to trigger them. Probably more because it's a timing issue, not necessarily because it's difficult. When the conditions are right, you probably can trigger wet slabs. Contributing factors, usually loading wind-drifted snow or loading new snow. Same thing on the loading side. Wet avalanches, rain, prolonged melting, very warm temperatures. We're looking at that energy issue that Andrew's getting into there. He didn't touch on rain. And, it is something that can put a lot of free water into the snowpack really rapidly. Also a lot of heat. You're putting a liquid into a frozen snowpack. How do they flow? Dry slabs, dry avalanches are fast. Wet avalanches are slower, like concrete. They tend to follow the terrain that they're in. They don't ramp up and blow up into create new trim lines on the sides. They stay in more confined gullies or more flowing. So the big take-home point there, dry snow generally fails due to an increasing load on the top of the snowpack, versus wet snow is generally failing due to a decrease in the strength of an existing layer. Really important for us. What are the implications of that? If we want to look at wet snow or dry snow avalanche hazard or stability, we can measure how much load we're getting, right? We measure snowfall, snow water equivalent. We over time develop a pretty good sense for, you can watch it. Think, ooh, it's loading up a lot. It looks like it, you just know. Versus wet avalanches, now they're failing due to a decrease in the strength of an existing layer. So one, you can't see it. You can't look down into the snowpack at whatever that weak layer of concern is. A lot of the times you don't even know where it is, which we'll get into here in a little while. But it's really hard for a person to be able to get a sense for when you should be worried. So a real fundamental difference there. It's a real problem with how people look at dry snow and wet snow. So this gets back a little bit more on something that Andrew covered. Dry, moist, wet, very wet, and slush. And my first introduction to this was I was on exchange at Snowbird, and I got lucky as far as who was skiing around with. I got to ski around with Liam Fitzgerald for the better part of a couple days on a nice spring, a little bit of a spring wet event. And he used something called the squeezificity scale before this even existed, which was basically the same thing as a precursor to it. He just based it all on snowballs. Dry snow, can't make a snowball. Temperatures below zero, it's cold. No free water, moist. Temperature is zero, key point there, right around zero. If you're going to get free water in the snowpack, you got to have temperature be around zero. Here you can make snowballs, nice and easily. The water content's less than 3%. Why is that? Why do you think 3%? Well, once you have free water going into snow crystals, there's going to be a certain amount of water that will just stick to the snow crystals due to surface tension. So the layer of snow is going to be able to hold roughly 3% by volume just based on that surface tension before you're going to actually have water droplets moving around. And these snowballs, you can make a snowball, but when I throw one and hit Chabot if he's not paying attention, just kidding. It won't really hurt him. It'll just kind of wake him up like that. Then you have wet snow. It'll get a little wetter, 3 to 7 or 8%. That's that pendular regime, and the words pendular and funicular came from Colbeck. He applied them from a different material science. I'm not sure what famous snow researcher guy. But anyhow, wet snow, again, temperatures around zero. You can see the water, 10 times magnification. I haven't looked at wet snow enough to be able to identify that well by looking at it. But you can make a snowball this time that is a little bit stiffer, so when I throw it and hit Chabot, it says, "Ow, asshole." He doesn't like it this time. And then we have very wet. There's a big difference here, that when we switch to that funicular regime, now instead of the snow crystals being surrounded by air with water droplets moving through, snow crystals are surrounded by water with air droplets here and there. So water flows, and it really drastically changes the properties of snow. Again, snowball test. Now when you make a snowball, you're going to squeeze water out of it. So you make a snowball and you'll actually see water drip out. So you're making an ice ball. So now when we hit Chabot, now it really hurts. It might knock it down level. It's really bad. And then slush, you can't make a snowball. Everyone knows what slush is. So kind of clear on that? So this is something that Simon came up with. There are no numbers on it. It's more a visualization thing. But as you have water content down here, strength of snow there, as snow starts to get wet, as it's moist and then beginning to get wet, it actually gains strength. It doesn't get weaker right away. You can make a snowball. Those snowballs, they get harder and harder. Then you get to some point up here where the strength dramatically falls off. And that's right around that 7 or 8% by volume, where the properties really start to change. So we'll touch on a real brief overview of the different kinds of wet avalanches. Wet loose, you have layers, whether they're superficial layers or deeper in the pack, they become very wet, so over 8%. Water content, you get a lack of cohesion. And then you generally need a trigger though to get these things going. Whether it's a person, whether it's a little roller moving down, whether it's a rock or a pine cone, it doesn't take much when the conditions are right, but you tend to need some sort of trigger hitting the surface of the snow. Wet slabs, on the other hand, free water accumulation is affecting some pre-existing weakness in the snowpack. And Eric's going to talk about this a bunch, so I'm not going to hit on it much here. But one of the other big differences is you don't need a trigger. And this picture is a good example. There's some pinwheels over here. This is a slide in a big standing bowl after the ski area closed. But nothing coming down from above that hit this thing. It just failed by free water coming down and hitting some pre-existing weak layer in the snowpack and causing that avalanche. So glide avalanche, you have free water accumulating at a basal interface down low in the pack. Follows periods of increased glide, maybe. I'm no expert on this. Don Sheriff's going to talk about this later today. I think we'll learn a little bit about it. Generally in areas with an impermeable layer at the bottom of the snowpack, so there's smooth rock, you hear about them out in California on those granite faces, grass, mud, something like that, or a pavilion over here a few blocks away. I just happened to be driving by about 2 months ago and saw these cool glide avalanches kind of happening and going on. We won't watch the whole thing because it gets a little boring just watching snow very slowly. But it was kind of interesting to see, kind of a neat process. As far as characterizing wet snow avalanches versus dry snow avalanches, wet loose, wet slab, it's kind of like that hard slab, soft slab. There is a gray area. It's not just a flashing light that says this was a wet loose avalanche when you come across it. You get some good clues though from the debris. A lot of times you can squeeze water out of the debris. On the bed surfaces, you'll see evidence of these striations with snow sliding down it. There's, pretty obvious that's a wet loose avalanche. And then sometimes you see really deep runnels compared to dry avalanches where it just gouges and kind of entrains everything with it. Tends to not ramp up into the woods. If this was a dry slab or a slough, it probably wouldn't have had enough momentum, been going fast enough, and it would have ended up over here and not made that sharp turn like that well. And the key thing, it's all about water with all, whether it's wet loose or wet slab.